Here we are at the warm-up for our 2.2, number 3 set of notes. We're asked to find the first derivative of this particular function. F of x is equal to x cubed minus 3x. Now again, using the definition of our derivative, we know that to find f prime of x, that's equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. And so pretty much anywhere that there is an x, we're going to go ahead and throw in this x plus h into the function for x. So then we end up with the limit as h goes to 0 of, instead of x cubed, we have x plus h cubed minus 3 times x plus h. So that would constitute as our entire first part right here minus our f of x. Well, here is our f of x, our function, x cubed minus 3x. And again, this is all over h. From here, it's pretty much just algebra and simplifying. So we end up with the limit as h goes to 0 of x plus h times x plus h times x plus h minus 3 times x plus h minus x cubed minus 3x. And again, this is all over h. Going ahead and foiling the x plus h's, we end up with x squared plus 2xh plus h squared, just foiling the first two. So times x plus h minus 3 times x plus h minus x cubed minus 3x all over h. Going ahead and distributing, we end up with the limit as h goes to 0 of x cubed x squared times h gives us positive x squared h. 2xh times x gives us 2x squared h. 2xh times h gives us 2xh squared. Moving on to the last term, h squared times x gives us xh squared. And then h squared times h gives us h cubed. And this is minus, distributing in this negative 3 to both items, we see that it comes out to be negative 3x minus 3h. So that would be the entire first piece with all the distribution. Then we have minus x cubed minus 3x all over h. Combining our like terms on top, we end up with x cubed. It looks like x squared h can be combined with this x squared h. We notice that this one has a coefficient of 1, and then this guy has 2, so it looks like we end up then with a total of 3 x squared h's. I'm just going to cross them out so that we can see that they're already done. We end up also with 2xh squared. Here's another xh squared, so it looks like we have a combined total of 3 xh squareds. And then plus h cubed minus 3x minus 3h minus x cubed minus 3x. And again, this is all over h. Simplifying things even further on top, we have the limit as h goes to 0 of, it looks like these x cubes end up canceling out because we have x cubed really minus x cubed, so those are gone. And then likewise we have negative 3x minus a negative 3x, so really we would be adding that second 3x. And thus these 3x's end up canceling out with one another. So on top we're only left then with 3x squared h plus 3xh squared plus h cubed minus 3h all over h. And from here we can go ahead and factor out an h on top. So then we end up with the limit as h goes to 0 of h times 3x squared plus 3xh plus h squared minus 3 all over h. Here you can see that they cancel out. And now we can go ahead and use our direct evaluation with what we're left with. So we still have this 3x squared, 3x squared plus 3xh plus h squared minus 3. Kind of the nice thing is pretty much anything that has an h is just going to come out to be 0. So this is going to be 0, this is going to be 0. So we end up then with 3x squared really minus 3. And again, that would be our derivative of this function. So again, though, that is the warm-up from our 2.2 number 3 set of notes.